Genius! Today, we are going to talk about the cube root of the number one. What am I talking about? Let's go to the whiteboard. Whiteboard and the new whiteboard. Okay, great. So, the cube root of the number one, or 1 to the power 1/3. So, if that equals some number a, then that would mean that a to the third power equals 1. I know what you're all thinking. That could be the number 1. 1 to the third power, meaning 1 times 1 times 1 does in fact equal 1. Are there any other numbers with this property? It's not -1. -1 times -1 is 1. The negatives cancel. Times -1 is -1. So that's not 1. Well, we know that there have to be other roots because of the fundamental theorem of algebra. The fundamental theorem of algebra states, let's make this large. Fundamental theorem of algebra. The number of roots of a polynomial is equal to its order. It may be phrased differently in your textbook, if you even have a textbook, because people don't use textbooks anymore. But that's basically what it is. So, for example, if you have x to the fourth plus x squared equals 7, to get roots of a polynomial, what we're talking about is when a polynomial equals 0 and we solve for x. So we would need x to the fourth plus x squared minus 7 would have to equal 0, right? And so there are 4 roots. Now there might be double roots, and we can get to that later, but there's got to be 4 roots. Okay. Well, for our situation, if x to the third equals 1, then x to the third minus 1 equals 0 would be that equation that the roots would help us solve. And so there must be 3 possibilities for x here. X to the third equals 1. Okay, so it looks like a pretty simple situation, but I can't think of any other numbers that I can take 3 of the number that I'm thinking of, and multiply them all and get 1. They're actually complex numbers. Complex numbers, a plus bi. So there's got to be a and b such that a plus bi to the power 3 equal 1. Now, we did have a video on things like the square root of I, the cube root of I, the fourth root of I, of negative I, etc. And we're actually going to use some of those concepts. So if we're thinking of any complex number as sort of a vector here, where this is the real axis and this is the I-axis, right? And here is 1, because it is 1 plus 0 times I. We don't go up and we don't go down, right? If that makes sense. And this is 0 degrees from this like 0 axis, right? To get to 0 degrees, what can we do 3 times? Well, 0 degrees is 360 degrees. If it's 360 degrees, we need 120 degrees. And 120 degrees will be here. I'm going to link to a video that might be like a preliminary video to this one that sort of helps you understand how that works. But if we have 120 degrees, that's somewhere here, because this needs to be 60, right? Okay. So what we want is this point, and it's on the unit circle. So if it's on the unit circle, that means that this is 1, right? And this is 60 degrees. 60 degrees. And that means that the length of this is square root 3 over 2, right? Because the sine of 60 degrees is square root 3 over 2, if I remember correctly. So square root 3 over 2. And this has got to be 1/2 because the cosine of 60 degrees or the sine of 30 degrees. So this is 1/2, except it's negative 1/2 because we're actually in this quadrant here where the x is negative. So what we actually have is negative 1/2. That's how far we go on the real axis. Sorry for this terrible writing. Yeah. Plus square root 3 over 2i. And that should be the number. And when we take this to the third power, that should be 1 or 1 plus 0i, hopefully. Somebody please check. I might do another video actually checking this. And as a bonus, find another cube root of 1 and comment your answer. Or comment how you found another cube root of 1. Meaning another number that may be a complex number, such that that number a to the power 3 will equal 1. And also check this, which I think I'm going to upload a video doing. All right. Thank you for watching. Subscribe, comment, share. Yeah. Thank you.